The law of entropy is a lie, and science proves it. The thermometer fell while the room got louder. Coffee cooled. A server rack hummed hotter. My professor tapped the gauge and said, "That's entropy writing the future." Then the lights flickered, power rerouted around a failing unit, and the noise dropped as temperatures evened out. The future changed in seconds. If entropy rules everything, how did the system steer itself? Get this, entropy's inevitable death story leaves out the ledger that decides what's kept and what's thrown away. Black holes, horizons, quantum bookkeeping, they flip the script. Tonight we'll expose the loopholes, the evidence, and what it means for time's arrow. To see the crack, start with the rule nobody thinks can bend. What entropy really is, and why we got it wrong. Entropy sounds like doom in one word: disorder. Ice melts. Rooms get messy. Hard drives fragment. The universe, we're told, drifts toward gray sameness. That story shaped how we talk about meaning, progress, purpose. Why build if heat death wins? But the stake is sharper. If entropy is a bookkeeping choice, not a tyrant, the future is a design problem, not fate. What actually is entropy? Not messiness. It's counting. Take a box of gas. The macrostate is what you can describe with a few numbers: temperature, pressure, volume. The microstate is the exact positions and velocities of every molecule. Many microstates correspond to the same macrostate. Entropy, in Boltzmann's spirit, is the logarithm of that count. More ways to realize the same macro equals higher entropy. That's it. A measure of information you discard to get useful predictions. Coarse graining is the quiet move. You choose which details to ignore. In the classroom, the gas in a box looks uniform. You don't track each molecule ricocheting. You blur. That blur is powerful. It gives you laws like the ideal gas rule, but it's also a choice. Change the blur, change what you call entropy. Entropy depends on description and access. Perspective matters. A micro story. A teacher pulls two identical decks of cards from their boxes. One is perfectly ordered, the other shuffled. To most eyes, the second looks high entropy. Then the teacher reveals the shuffle is a specific permutation written on the board. To someone holding that key, the random deck is a single microstate with a short description, lower algorithmic complexity than you'd think. Same cards, different knowledge, different entropy assignment. The moral lands. The number isn't sacred, it's conditional. So why does time have an arrow? If microscopic physics is mostly time-symmetric, you could, in principle, unscramble eggs. In the 187s, Joseph Loschmidt asked exactly that, and the standard answer leans on typicality. Given a low-entropy macrostate, most microstates evolve toward macrostates occupying more of phase space. But that line hides a deeper mystery: the past hypothesis. The universe began in a very special, low-entropy configuration. With that one boundary condition, arrows emerge. Memories point backward, radiation spreads outward, cooled coffee doesn't spontaneously heat. Without it, you'd expect Boltzmann brains, freak observers from thermal noise, more often than galaxies. Our reality looks nothing like that. So the crucial question isn't why entropy increases, it's why it was so small to begin with. Here's the everyday braid. Your fridge cools by dumping heat into the room. Its local entropy decrease is funded by an increase outside. Your brain learns by burning glucose. Order in synapses gets paid for with waste heat. Engines, ecosystems, neurons, all export entropy to build structure. That's not cheating the second law. It's the second law for open systems. The law is global and statistical. Life thrives in the gradients. Now the complication. If micro-laws are reversible, why don't we see large-scale unscrambling? Because records. Once information leaks into many degrees of freedom, air molecules, photons off a chair, bits in memory, the alternatives that could interfere get buried. Decoherence enforces a practical arrow. Histories separate when information spreads irreversibly. Erasing those records has a cost, Landor's price tag of KTLN2 per bit. Information is physical. Forgetting heats the room. And yet, if entropy is statistical, where does the certainty in doom talk come from? It comes from forgetting the ledger is patch-bound. We live inside horizons. causal boundaries that cap what can be accessed and stabilized. The second law applies to what's in play for us, given our coarse graining within our light cones. When we inflate that into an absolute cosmic verdict, we overreach. Another human moment. In a data center, a technician reroutes airflow. The temperature map on one dashboard shows smooth blue. A second dashboard with higher resolution reveals hot filaments carrying waste from optimized workloads. Same room, two macrostates. Smoothness in one view, structured currents in another. Efficiency isn't uniformity. It's targeted order funded by managed disorder elsewhere. This reframes the past hypothesis as design input, not metaphysics. A low entropy beginning sets up gradients. Inflation can compress and smooth, writing a tiny instruction set that later physics amplifies. But even before we reach cosmology, notice the policy. Entropy is a bookkeeper for what we decide to track. The arrow emerges when records proliferate. Responsibility returns when you realize which records you choose to make durable. One more pivot. Entropy increases because most macrostates swallow more microstates. True, but most is under a measure you chose. Physics keeps handing us measures that align with what we can access: energies, temperatures, densities. Horizons will refine that. Black holes will shove a new ledger in our hands: area, not volume. And quantum bookkeeping will force us to count entanglement, not just particles. Each step narrows our claims about doom and broadens our tools for agency. So no, entropy didn't lie. Our picture did. We sold it as fate when it's guidance. We called it chaos when it's counting. We treated it as universal law when it's statistical policy that depends on what you can ask and copy. If that feels like a downgrade, hold the feeling. It's the upgrade that lets us steer. Meanwhile, if the rule is statistical, where does the certainty come from? From places where nature hides and reveals records at once: horizons. The arrow problem: why time flows one way. If entropy is counting and records make arrows, here's the stake. Memory, causation, responsibility, they all lean on one direction. You remember breakfast, not dinner 3 days from now. You can apologize for last night. You can't pre-apologize for next Thursday and make it land. If the microlaws are reversible, why does your life feel welded to one timeline? Start with the clash. Newton's and Schrödinger's equations run clean in both directions. Reverse velocities in a billiard simulation or complex conjugate a wave function, and the math rewinds. Meanwhile, thermodynamics says coffee cools, eggs scramble, iron rusts. In the 187th, Joseph Loschmidt posed the paradox plainly. If the laws are time-symmetric, why don't we ever see a scrambled egg unmix? Boltzmann answered with typicality. From a low-entropy macrostate, most microstates evolve toward larger phase space regions. But typicality piggybacks on a special past. Without that past hypothesis, a very low-entropy beginning, you don't get the arrow you live. Now take it personally. Memory is a physical record, not a ghost. Neurons strengthen synapses. Photons scatter off a notebook page. Hard drives flip magnetic domains. To store a bit, you eventually erase a bit, pay Landwehr's cost, and dump heat. That heat isn't side noise. It's the bill that keeps arrows honest. Your recollection of a promise is tied to entropy you exported when you wrote it down or rehearsed it aloud. If the past were as plastic as the future, those records would reverse too. They don't, they accumulate. A human moment, you open your freezer. Cold air spills, your skin prickles, the compressor kicks on. The fridge isn't making cold. It's pumping entropy outward, riding a gradient, paying in electricity and heat. Local reversal funded by a larger increase. That's the arrow braided through daily life. The same braid holds your inbox. To reduce clutter meaningfully, you spend attention and burn glucose. Organization is purchased. But this still dodges the unnerving bit. If microlaws are reversible and decoherence is just entanglement growth, why don't we witness large-scale unscrambling? Because records don't stay local. Once information about a configuration has spread into zillions of degrees of freedom, air, dust, radiation, the alternatives that could interfere are functionally gone. Not destroyed, exiled into correlations across a space you can't access. You could, in principle, recohere a shattered vase by reversing every environmental interaction. In practice, you'll never gather the photons that carried the news of the break. Information that escapes becomes context, and context picks the story. Meanwhile, something else anchors the arrow. Causality is geometric. Draw your light cone. Events inside your past cone can touch you, events outside can't. That cone isn't negotiable, it's light speed carving the network of influence. Temporal order outside each other's cones is frame-dependent, but inside cones, before and after have teeth. Every real cause you name is a chain of records propagated within cones. Reverse the chain and you run into missing links, signals that never existed because nobody paid the cost to create them. Loschmidt's punch still stings. If you could prepare the right microstate, velocities tuned just so, the air in this room would gather in a corner and chill your hand. Physics doesn't forbid it. Preparing such conspiratorial conditions would require mirror precision control over every prior interaction. That control is another ledger. Specificity is expensive. The arrow hides in the price of precision, not in a mystical push from time. Then the trap called the Boltzmann brain. In an equilibrated universe, rare fluctuations could briefly assemble minds with fake memories, far more often than whole low-entropy histories like ours. The fact we perceive a vast, consistent past argues we're not such fluctuations. It nudges us back to the past hypothesis. Our cosmic initial condition was astonishingly simple, and inflation likely spread that simplicity. Compression followed by expansion, writing a minimal program whose output looks like a rich history. In that frame, the arrow isn't stamped on equations. It's a boundary condition plus a planet of record makers generating heat as they copy and recopy. Here's where it gets practical. Causation isn't metaphysical oomph, it's stable counterfactuals in a noisy world. You act from reasons because your brain is a prediction engine exploiting gradients and redundancy. Responsibility lives in engineering. Did you set conditions so reasons you endorse win more bids? Sleep, social contracts, institutional scaffolds. These tilt thresholds so histories that keep paying forward beat histories that burn out. The arrow gives you leverage if you acknowledge the ledger. One last scene. A physics lab runs a spin-echo experiment. Random interactions scramble nuclear spins, signal fades, the arrow in miniature. Then a timed pulse flips phases and the signal reappears, a ghost of order recovered. You can claw back structure locally with care and cost, but the lab closes, the building radiates heat, the Earth beams infrared into space. Arrows braid, local reversals riding on global increase. The future isn't written by entropy alone. It's negotiated by who pays to make which records stick. Black hole thermodynamics, when entropy gets a new boss. Meanwhile, the ledger we've been teasing shows up where gravity draws a hard boundary. A black hole isn't a thing in the everyday sense. It's a region with a rule. Cross the event horizon and no causal signal returns. That rule turns entropy from volume counting to surface bookkeeping. The stakes couldn't be higher. If horizons set budgets, then our doomed story forgot who holds the wallet. Action first. In 1972, Jacob Bekenstein asked an uncomfortable question. If you throw a cup of coffee, full of heat, molecules, information, into a black hole, doesn't the second law flinch? Outside, entropy goes down. His fix sounded like heresy at the time. Assign the black hole an entropy proportional to its event horizon area, not volume, area. Then in 1974, Stephen Hawking did the unthinkable calculation. Quantum fields near the horizon don't sit silent. They generate radiation with a thermal spectrum. A black hole has a temperature inversely proportional to its mass and radiates like a body with entropy S equals A4 in Planck units. The heresy became a theorem's whisper. Horizons are thermodynamic. Impact immediate and weird. Surfaces tally bits. The bulk obeys the boundary ledger. That flips every instinct. Double the mass, the area doesn't just double, it scales with mass squared. Your intuition that more inside means more entropy fails. The horizon area is the book's cover. The interior chapter count never lands on your desk. That's the generalized second law. The sum of the outside entropy plus the black hole's area entropy never decreases. Toss in your coffee. The horizon grows enough to pay the bill. No cheating, just a new accountant. Micro story. A graduate student stands on a catwalk above a ring of liquid nitrogen tanks in a cryo lab. They joke about tossing a hot mug into one to see the boil. The advisor grins, then sketches a black circle on the whiteboard. "Do it here instead," he says, and the area goes up more than your steam cost. Outside looks tidier because the boundary paid extra. The student nods at the absurdity that lands as sense. The book never loses pages, it moves them to the cover. But there's a complication sharp enough to cut the subject in half. Hawking radiation is thermal, featureless. If a pure quantum state collapses and the whole evaporates to a mixed soup, information seems gone. Unitarity, the promise that quantum evolution preserves information, would break. That's the information paradox. We either scorch quantum mechanics or rewrite our gravity storytelling. Decades of argument followed. Before we jump to modern resolution attempts, feel that crisis where it lives. A horizon with a temperature means a horizon with microstates, but we don't know their identity in our universe. In toy worlds, de Sitter spacetime, holography gives a dual quantum theory on the boundary that counts them. In our de Sitter-like cosmos, the dual is unfinished. So the area law is a lighthouse, bright, reliable, distant. It guides, but we haven't reached shore. Now the generalized second law plays like a courtroom drama. Drop a memory stick into a black hole. Out here, your records decrease. The horizon grows by an amount set by energy and redshift. The sum increases. Later, as the hole evaporates, outgoing radiation carries entropy away. Early on, that radiation's entropy rises. It looks even messier outside. If the process were truly thermal to the end, the outside would be left with noise and no imprint of what fell in. That would shatter the global ledger. Meanwhile, something else is happening across town in cosmology. A universe with accelerated expansion has a horizon too. Gibbons and Hawking showed de Sitter space has a temperature and an entropy proportional to its horizon area. Not just black holes, cosmic horizons also keep accounts. Your causal patch has a finite bit budget scaling with its edge. Facts stabilize inside. Beyond, correlations can't be fetched. The ledger is patch-bound, not parochial. That echoes our claim. What you can copy and cross-check depends on access. Horizons are the access policy. Back to the paradox sharpened. If the horizon encodes the missing information, how does it get out? Hawking's original calculation ignored back reaction and entanglement structure at late times. The outside modes were entangled with interior partners, not with early radiation. If that stayed true throughout, late radiation couldn't also be entangled with what already escaped. Quantum monogamy would be violated. The neat horizon would have to become a firewall, torching smoothness to protect unitarity. No one liked that. The equivalence principle, the promise that free fall is dull at the horizon, would fail. Here's where the new boss flexes differently. Counting by area suggests that what we call inside may be a story told from outside via correlations. The ledger lives on slices of geometry, apparent horizons, extremal surfaces, that decide which degrees of freedom you're allowed to reconstruct. You don't need to post a guard at the horizon. You need to count correctly. This is the seed of a resolution. Redefine which region's entropy you're measuring and when, and the ledger balances. One more human beat. A computational physicist stays late, running a toy model of a black hole coupled to a radiation bath. The plot on her screen shows the radiation's entropy rising, cresting, then bending down. She exhales a laugh in the empty office. "Okay, boss," she says to the flat, glowing curve. "You win. Surface first." The black circle on her whiteboard suddenly looks less like a hole and more like a vault door that also prints receipts. Moral is blunt. Horizons don't repeal the second law, they complete it. They change the units at the edge and force us to count entanglement, not just molecules. The doom story shrinks again. The The rule is everything decays to featureless waste. It's everything the ledger lets you access tends toward typicality, unless the boundary has room and a mechanism to store structure. Black holes make room. And in the next act, the curve that bent on her screen will tell us why nothing was truly lost. The page curve in islands. Ledger balances after all. This was the moment the ledger blinked and changed hands. For decades after 1974, Hawking's calculation said the entropy of Hawking radiation just climbs, straight line, no bend, until the black hole is gone. Translation: outside looks noisier forever and the story of what fell in never comes back. If that were true, the global book wouldn't balance. Unitarity would break. But the new boss, surface counting, entanglement, horizons as interfaces, hinted we were holding the wrong ledger at the wrong time. Action first. In 1993, Don Page made a daring forecast based on simple quantum bookkeeping. If evaporation is unitary, the fine-grained entropy of the radiation shouldn't climb forever. It should rise at first because early photons are entangled with the interior, hit a maximum at roughly the halfway point in evaporation, the Page time, and then fall as later radiation carries out correlations that complete the record. Plot it. A hill that crests and returns to zero. That's the Page curve. Hawking's straight ramp had to bend. But nobody knew how to compute that curve from gravity itself. The breakthrough arrived with a magician's modesty. Don't add new physics. Count the right region. Using ideas from holography and quantum extremal surfaces, theorists defined the entropy of radiation not by naive partitions, inside versus outside, but by extremizing a generalized entropy that includes an area term plus bulk entanglement. Early in evaporation, the dominant surface excludes the interior. The radiation entropy rises. After the Page time, a new surface, an island just inside the horizon, enters the game. Now, when you compute the radiation's entropy, you include the island's degrees of freedom as effectively part of the radiation's entanglement wedge. The curve bends down. Ledger balanced. What's an island in plain speech? It's a region that you, as the accountant of the radiation, are allowed to reconstruct from the correlations you already hold, even though it sits behind the horizon for someone else. Think of it like this. You've been quietly collecting scrambled printouts for years, early Hawking quanta. Alone, they look like noise, but after enough pages pile up, a pattern emerges. A new set of missing pages, the island, becomes recoverable in principle from your archive. Information wasn't destroyed. It moved its address on the ledger. Micro story. A grad student schedules midnight printer time to push through the island papers. She highlights a line, sketches a little worm of an extremal surface on scrap, and watches a plotted entropy that rises, peaks, then falls. She whispers, "The curve finally bends." Relief, then a headache. If islands rescue unitarity, what happens at the horizon for someone falling in? Smooth or a firewall? Impact immediate. The Page curve computed with islands matches the quantum expectation. Unitarity wins. No net loss of information. The ledger doesn't leak, it reallocates. Bits that look trapped behind the horizon are, after the Page time, effectively encoded in radiation correlations you can access in principle. That's the Hayden Preskill mirror intuition sharpened. Toss in a diary after the black hole scrambles, wait a scrambling time plus some. Then with an absurdly powerful decoder, you could, in principle, extract the diary from the outgoing stream. Nobody's building that decoder this century. That's fine. Physics only needed the book to balance, not a thief to read it. But there's a complication that refuses to leave quietly. If late radiation is highly entangled with early radiation to recover information, how can it also be entangled with interior partners behind a smooth horizon? Quantum monogamy says it can't be maximally entangled with two independent systems. That's the firewall puzzle. One door invokes state dependence and quantum error correction. Bulk operators behind the horizon are reconstructed from different boundary subspaces depending on the global state. No illegal cloning, just clever encoding. Another leans on complementarity. No single observer can verify both the smoothness and the detailed decoding. For the infaller, the horizon stays dull. For the distant archivist with impossible patience, the news is in the radiation. Same backend, different dashboards. Meanwhile, the island rule generalizes beyond black holes. Cosmological setups with horizons inherit similar bookkeeping. What counts as the system depends on your patch, your access, and the extremal surfaces that fence your wedge. Entropy becomes less a measure of universal mess and more a policy for which correlations are stably accessible to which observers win. That's the real flip. The second law didn't lie. Our picture did. We forgot to ask whose ledger, over what region, and on what schedule. Here's the stake that loops back to agency. If information can be hidden, transferred, and later recoverable by the right collector with enough redundancy, then what you stabilize matters. Redundancy wins. Copy storms make facts subjective. Waste dies because nobody pays to keep it. The universe doesn't keep every detail explicit all the time. It stores minimally and encodes cleverly on boundaries. Efficiency is the law behind the laws. One last human beat. A theorist pushes back from his desk at dawn, knuckles aching from algebra. On the board, SR up, crest down, a tiny island like a lifeboat just inside a horizon. He texts a colleague, ledger balances. Then adds, about that firewall, the reply pings, different dashboards, same backend. He grins, kills the lights, and leaves the curve glowing on screen. The first honest plot of nothing was ever lost. Holography, surfaces encode the world. Here's the pivot that sounded like science fiction and then refused to let go. If black holes keep their books on the horizon, maybe nature does that trick more broadly. Not we live in a simulation, but a harder claim. The right surface, with the right rules, can encode what happens in the volume. Holography isn't a metaphor. It's a working lab for gravity. Action first. In 1997, Juan Maldacena uncovered a shocking equivalence now called AD-SCFT. Take a universe with gravity living inside a negatively curved bulk, anti-de Sitter space. Put a quantum field theory without gravity on its boundary, one dimension down. Against every instinct, the two descriptions match. An excitation on the boundary maps to a ripple in the bulk. A black hole inside corresponds to a hot fluid outside. A dictionary, not a slogan. Geometry here, entanglement there. Impact immediate. The area law we met at Horizons wasn't a one-off. In holographic ground states, the entanglement entropy of a region scales like the area of its boundary, not its volume. In 2006, Shinsei Ryu and Tadashi Takeyanagi sharpened it. To calculate the entropy of a boundary region, find a minimal surface hanging into the bulk whose edge matches the region's boundary. Its area, divided by 4 in Planck units, gives the entropy. Surfaces, again, tell you how many bits belong to a chunk of the world. Glue regions together and those minimal surfaces rearrange. Connectivity in the bulk mirrors who shares information on the edge. Space looks stitched from entanglement. Micro story. A coder sits in a dim apartment, watching a tensor network visualization breathe. Nodes flare, links thicken, the web flexes like a lung. She drags a slider. A ragged room reassembles from seams, edges first, interior second. It's like the wallpaper renders the furniture if the seams line up, she mutters, then laughs. The math doesn't simulate a house. It simulates a toy holographic code where losing some boundary patches still lets you reconstruct simple bulk operators. That resilience isn't magic, it's error correction. That's the next reveal. In good holographic toy models, the bulk-to-boundary map is an error-correcting code. Bulk information is redundantly encoded across many boundary degrees of freedom, so you can lose parts of the edge and still recover the interior. That's why horizons can stay smooth for infallers, while distant decoders reconstruct behind the horizon operators from different boundary shares. No cloning. Different reconstructions from overlapping datasets. Complementarity gets teeth. But there's a complication we can't dodge. Our universe isn't anti-de Sitter. It looks more like de Sitter, positively curved, expanding, with a cosmological horizon no one has fully dualized. The clean add SCFT dictionary doesn't copy-paste. Even so, area laws keep showing up. Ground and low energy states obey them. Quantum matter across scales exhibits entanglement that hugs boundaries. The page curve and islands rely on extremal surfaces that echo Ryu, Takuyanagi in spirit. The pattern is loud even if the exact dictionary is missing. Meanwhile, something else hums across town in quantum Darwinism. Decoherence doesn't just kill interference. It spreads pointer information into many environment fragments. Multiple observers read the same story from different shards, photons bouncing off a table, dust grains, air. That redundancy feels wasteful until you remember error correction. Copy storms stabilize facts. The world looks crisp because the same bits are recorded many times on accessible surfaces. The light that reaches your eyes, the pressure waves that hit your ears, the voltages a sensor reads. Objective reality is a hologram in practice. Details ride interfaces that many can query. Here's the stakes line that bites our doom story. If bits scale with area, not volume, full volume entropy was the lie. You never had the budget to store every microscopic detail explicitly. Nature saves by committing what can be asked and inferred within horizons and leaving the rest implicit, constrained by symmetries, redundancies, and consistency. That's compression with receipts. You don't lose predictive power because the questions you can physically pose don't require the missing bits. Efficiency as policy. Micro story. A telescope team dials in an observation near a galaxy cluster's rim. Their lensing map, just a distortion pattern on the sky, reconstructs a mass distribution they'll never touch. It's like the edge told on the middle, a postdoc says. The pi nods. Holography is a habit long before it's a theorem. They don't mean ad s, they mean a practice. Measure boundaries, invert constraints, extract the interior to the precision the data allow. Complications deserve honesty. Ad s holography is exact and spectacular. For our de Sitter-like patch, we have hints, not a completed duel. Any confident the universe is a hologram claim outruns the ledger. Still, the discipline pays off even without a perfect dictionary. Entanglement builds geometry and models. Minimal surfaces compute entropies that match page curves. Quantum error correction explains how interior operators evade firewalls for honest observers. And the area law keeps whispering, budgets live on edges. Now haul this back to agency. If surfaces decide which bits stabilize, then efficiency, minimal commit, maximal redundancy, chooses what the world keeps. Facts that spread across many channels survive. Ones that don't fade. Institutions that copy, verify, and archive earn reality's attention longer than ones that hoard. Physics isn't moralizing. It's offering leverage. Push information to interfaces others can reach, and it persists across bad weather and time zones. A last beat before we lift our eyes to the sky. Holography reframes inside and outside as viewpoints tied to access. The boundary isn't a wall, it's an API. Change your access, change the code path that reconstructs the bulk. Different dashboards, same backend. That's not mysticism. It's the price of living where counting happens on edges and meaning travels with redundancy. And it sets up the next move, running this logic across the first big edge you and I share, the cosmic horizon. Inflation, the universe's first compression. Now pull the camera back to the biggest edge of all, the beginning we thought we understood. If horizons hold budgets and surfaces store truth, then the universe's opening move looks less like an explosion and more like an audacious compression. Write a tiny instruction set, duplicate it everywhere, and let physics decompress the file into structure. Action first. In 1981, Alan Guth and Andre Linde shaped the modern inflation picture. Not just fast expansion, but exponential growth driven by a field whose potential energy acted like a temporary cosmological constant. In a sliver of a second, a causally tiny, smooth patch ballooned to encompass what would become our observable universe and far beyond. Regions that looked too similar to have ever talked were actually neighbors before inflation stretched them apart. The horizon problem dissolves. The flatness problem, Why space today looks so close to Euclidean. Dissolves too because rapid expansion irons curvature the way tugging a sheet pulls out wrinkles. That's compression masquerading as growth. Erase specific details, preserve a clean large-scale template. Here's the quiet masterstroke. Quantum fields never sit perfectly still, they jitter. During inflation, microscopic fluctuations got stretched to cosmic scales. Modes that started subatomic drifted outside the horizon, froze as classical-looking density and curvature seeds, then re-entered long after inflation ended. Gravity took those seeds and went to work. You can hear their fossil imprint in the cosmic microwave background's acoustic peaks, the early plasma ringing like a drum. The power spectrum we measure is close to scale invariant with a slight red tilt, NS around 0.965. That tiny deviation is a whisper about the slope of the inflatten's potential, the shape of the hill the field rolled down. Minimal inputs, maximal reach. A human moment. A theorist circles NS approximately 0.965 on a whiteboard and smiles. It's not a slogan, it's a checksum. The value the Planck satellite mapped onto the sky matches simple, slow roll models, smooth, gently sloped potentials. One number, red from microwave fuzz, pointing back at a field we haven't yet identified by name. Meanwhile, the entropy ledger flips perspective. Inflation looks disordering, space exploding, yet acts like the first Great Compression. It takes a messy pre-inflation patch and outputs a clean, nearly homogeneous background with a sparse set of correlations encoded as long wavelength modes. Think of it as writing a tiny header and a bit stream. Amplitude, tilt, a handful of densities. After reheating, when the inflatten's energy dumped into particles and radiation, the universe began decompressing those correlations into galaxies, clusters, and voids. The cosmic web is inflation's file, unfolded by gravity and time. The stakes are sharp. Without a low entropy start, arrows don't emerge reliably. Inflation supplies that start without fine-tuning every detail. It creates initial conditions where relevant macrostates occupy a vanishing slice of phase space, yet are duplicated across an enormous volume. So typical evolution produces structure like ours rather than Boltzmann brain noise. We didn't need the universe to press-store every microscopic fact. We needed it to commit early to a minimal, redundant set of large-scale facts, and inflation does that. Complications deserve honesty. Not all inflationary models survive data. Strong tensor signals, primordial gravitational waves, haven't been seen yet squeezing large field models. Subtle anomalies hang at the edges, low letter 2113 power deficits, curious alignments, hemispherical asymmetry. They're whispers, not verdicts. Some may be statistical flukes, some may hint at small features in the inflattened potential or pre-inflation physics. The core scaffolding, near Gaussianity, a slight red tilt, and those crisp acoustic peaks holds. There's also the speculative branch called eternal inflation. Quantum fluctuations can nudge the field uphill locally, so while our patch exited, reheated, and wrote its ledger, other regions kept inflating, budding bubbles with varied properties. That yields a multiverse picture. Evidence? None direct. Searches for bubble collision scars in the CMB haven't landed a clean hit. Keep it live but unclaimed. A micro story. A small team stares at CMB residual maps after subtracting foregrounds. Someone points at a cold patch and frowns. Another shakes her head. Selection after looking. They run blind analyses, swap pipelines, and watch the anomaly's significance wobble toward modest. The discipline isn't glamorous. It's how the ledger stays honest. Now fold inflation into our bookkeeping theme. By blowing up a tiny causally connected region, the universe set identical ledgers across vast horizons. Same background temperature, same statistical rules, same budget-constraining edges once dark energy dominates. The bits per patch scale with area, but the instructions per patch are stingy. Efficiency as policy shows up at the beginning. This reframes heat death talk. If the start was compression followed by efficient decompression, the far future might rhyme. Records thinned, horizons tightening quotas, information recoded at edges. Penrose's cycles are one provocative version, bounce models are another. We'll weigh those endgames soon. Hold the picture. The era we live was seeded by economy. Don't store everything. Store the few correlations that matter and copy them everywhere you can. One last beat before that fork. Inflation isn't a magic wand. It's a mechanism class that passes harsh checks, the sky's drumbeats, the tilt, the lack of wild non-Gaussianity. It turns the past hypothesis into plausible physics, not a metaphysical decree. And it locks our story's theme. Entropy's doom is really a budget. The universe opened by setting the budget low, the redundancy high, and the ledger readable from a boundary. The first compression that made room for everything to follow. Heat death or reset, the competing endgames. Everything we've built so far points at a blunt fork. Does the ledger wind down into silence, or does the universe find a way to reboot the arrow? Your future, meaning, agency, leans on which fate wins. Start with the quiet ending. Observations say dark energy dominates. Space expands at an accelerating clip, pushing distant galaxies beyond our event horizon. That horizon isn't a wall, it's a limit on who can ever talk to whom. Inside your patch, matter thins, stars gutter out, black holes slowly evaporate through Hawking radiation, and energy spreads so evenly that nothing macroscopic can form or compute efficiently. That's heat death, not fire but latency and low gradients, a cosmos that still exists but can't pay for new structure. The ledger isn't empty, its budget per patch is finite and written on the edge, but there are no cheap ways to turn that budget into long-lived records. Push the other extreme. If dark energy isn't a constant but a field whose pressure grows more negative, expansion can tear apart bound systems. Galaxies first, then solar systems, then planets, then molecules. Eventually even atoms if the equation of state drops hard enough. That's the big rip. It's spectacular and, for now, speculative. Current data huddle close to a cosmological constant. File it as a dramatic edge case. An end where the API that lets anything talk to anything else gets shut down by the backend itself. Or rewind. Suppose expansion slows, reverses, and the universe collapses. A big crunch. Gravity wins, temperatures soar, densities spike. Classic FRW models permitted if curvature or matter density were high enough. Our sky's flatness and dark energies push make a crunch unlikely today. Yet the appeal is obvious, a potential prelude to a bounce. That sets up plays that promise resets, not endings. One is Roger Penrose's conformal cyclic cosmology. Let an eon expand until only massless radiation remains. When everything massive decays or is swallowed and black holes evaporate, scale loses meaning for the survivors. In that regime, geometry forgets size. Rescale the infinitely stretched future and map it to the next Big Bang's beginning. No violent crunch, no bounce pressure. Just a change of units where angle, not length, matters. Evidence. Claimed concentric Hawking points in the microwave background have been challenged repeatedly. CCC is elegant, provocative, unproven. Another line is ekpyrotic/bounce cosmology. A slow contraction under a stiff equation of state smooths anisotropies and irons inhomogeneities. An inflation in reverse. Then a bounce, via brane collision or effective potentials, launches a hot expansion. Loop quantum cosmology offers a different trigger. Quantized geometry introduces repulsive effects at Planck densities, replacing the classical singularity with a quantum rebound. The hope is honest. Drain entropy's dangerous modes during contraction, then restart with a low entropy slice. The bill is itemized. Gravitational entropy in long wavelength modes, relic black holes, leftover anisotropies. They must be bled away or diluted. Each fix covers one leak and risks another. Predictivity demands that new seeds match the near Gaussian, slightly red tilted spectrum we see. Constraints mount, victory waits. Meanwhile, De Sitter thermodynamics cuts through romance. A patch with a positive cosmological constant has finite horizon entropy proportional to area, about 10^122 in natural units for our vacuum. If you're bold, that implies a finite Hilbert space dimension per patch, and with it, Poincaré recurrences on absurd timescales. Forever, inside one patch is an infinite novelty. It's a finite playlist that eventually repeats. Heat death looks like stasis with rare statistical flutters, not a stage for endless innovation. Eternal inflation tries to escape by budding new patches forever, but inside each, the budget remains bounded by the edge. A human moment. Picture an astronaut far in the future floating in a dark energy-ruled patch. The sky is nearly empty, the local group has long merged, black holes hiss faintly with hawking heat. Their suit analyzer reads a background temperature brushing the de Sitter floor set by the horizon. The interface is tight. They turn their head and feel a pang that isn't about oxygen. There's simply less to couple to. Agency is a bandwidth story, and the bandwidth fell. Yet cycles persist in small. Stars die, elements scatter, planets form, life appears, records propagate. Local arrows reset daily by gradients we engineer. The reset debate isn't only cosmic. It's the acknowledgement that within any budgeted universe, order reappears whenever flows can be tapped and copied, while the edge dictates the ceiling. That's why cyclic cosmologies, despite gaps, keep attention. They rhyme with lived truth, compression and expansion alternate, and resets are how complexity survives. There's the measure problem too. Even if cycles occur, how do you count histories? What counts as reset across eons when observers inside patches can only read their own interface? Tests. That's the rub. Across cycles, records are erased by design. You hunt for fingerprints in the CMB, subtle non-Gaussianities, peculiar alignments, residual phase correlations. So far, the core inflationary checksum, acoustic peaks, NS approximately 0.965, tight non-Gaussian bounds, keeps winning. Resets haven't delivered a clean, unique signature. So where does the ledger land today? The conservative bet-dominated heat death wins on data. Big Rip is a long shot. Big Crunch is out unless dark energy flips sign. Bounces and CCC stay intriguing, constrained, and searching for sharper footprints. What doesn't change across endgames is the boundary logic. Finite patch entropy, horizons as interfaces, and entropic costs for stabilizing truth. Here's the stake that loops back to you. If endings look like compressions, not voids, the smart move isn't mourning a silent ledger. It's investing in records that survive long lulls and thin channels. Design for latency, copy to edges, keep facts cheap to read and hard to erase. Whatever fate the cosmos picks, agency is the craft of spending a finite budget on structures that keep paying forward. The entropy reset debate. Can arrows reboot? If entropy is a ledger and horizons set budgets, the audacious question is whether the book can ever be closed and reopened. Arrows rebooted, debts forgiven. If resets are real, the second law becomes local theater inside bigger cycles. Heat death looks like an intermission, not a finale. Start with Penrose's move, conformal cyclic cosmology. Let an eon run to near emptiness. Massive particles decay or are swallowed. Black holes evaporate over unthinkable times. What remains is massless radiation and perhaps gravitons. No rest mass, no clocks, no rulers that survive scaling. In that regime, geometry forgets size. Penrose proposes you can then rescale that infinitely stretched late-time universe so its end maps conformally to the next Big Bang, S beginning. No violent crunch, no bounce pressures, just a change of units where angle, not length, matters. The arrow in each eon exists because black holes eat and hawking radiation redistributes. The arrow resets when scale becomes meaningless. Evidence. Claimed concentric hawking points in the CMB have been challenged by follow-ups. CCC remains elegant, provocative, and unproven. Now the bounce family. In ekpyrotic models, the universe contracts ultra-slowly under a stiff equation of state, smoothing anisotropies and ironing inhomogeneities, and inflation in reverse. Then a bounce, via brane collisions or effective potentials, launches hot expansion. Loop quantum cosmology offers a different mechanism. Quantized geometry introduces repulsive effects at Planck densities, replacing a classical singularity with a quantum rebound. The hope is honest: drain dangerous gravitational modes during contraction, then restart on a low entropy slice. But the bill is itemized. Long wavelength gravitational entropy, relic black holes, and leftover anisotropies must be bled away or diluted without spoiling the seeds we observe. Predictivity demands that the regenerated perturbations match the near-Gaussian, slightly red-tilted spectrum we see. Constraints mount. Decisive victory waits. There's the measure problem too. Even if cycles occur, how do you count histories? What counts as reset across eons when observers inside patches can only read their own interface? Tests, that's the rub. Across cycles, records are erased by design. You hunt for fingerprints in the CMB, subtle non-Gaussianities, strange alignments, residual phase correlations. So far, the core inflationary checksum, acoustic peaks, NS approximately 0.965, tight non-Gaussian bounds, keeps winning. Resets haven't delivered a clean, unique signature. A micro story. Two cosmologists argue over coffee. One draws a loop, compress, expand, fade, rescale, repeat. The other taps a CMB plot. Pretty, she says, but the sky still prefers inflation. They both smile. The first circles test twice. The second writes budget under horizon entropy. They're minding different ledgers. Meanwhile, arrows reboot locally all the time. Stars collapse into black holes and on timescales beyond patience evaporate, structure return to radiation. Galaxies quench and reignite. Planets boil and refreeze. Life exploits gradients, overwrites memories, and builds institutions that outlive founders. None of that breaks the second law. It leans on it. Local order increases while exporting entropy to a wider environment. Resets are domain-bound. Fresh arrows bloom inside bigger arrows that keep climbing. Translate to horizons as interfaces. A de Sitter-like patch hands each observer a finite entropy quota written on its edge, with a faint Gibbons, Hawking temperature humming at the boundary. When a patch empties, structure thinned, records faded, the interface remains. In Penrose's spirit, when only massless carriers survive, detailed records lose their teeth. Conformal structure outlives clocks. Whether that can power a genuine Ian-to-Ian handoff is open, but the intuition tracks our ledger theme. When nothing left can keep precise time, compression wins and budgets can be renormalized. Here's the stake that loops back to agency. If resets are global, they're invisible homework, across eons, not lives. If resets are local, they're our craft. A city that burns and rebuilds resets. A library that survives a regime change resets a civilization's arrow. An archive mirrored across continents outlives storms inside horizons. Physics doesn't bless intentions. It blesses redundancy, error correction, and honest energy bills. Arrows reboot where we design flows that can restart after shocks. So can the second law be broken? No. Can arrows reboot? Yes. Within domains that can dump entropy elsewhere, erase fragile records, and seed new gradients. Cosmology's grand cycles remain unsettled. The sky keeps its secrets. But at every scale we can touch, resets are the responsible use of a finite ledger. Compress, back up, broadcast, and be ready to decompress when a new cone opens. One last human beat. A coastal town rewires after a flood. Power substations move uphill. Data servers mirror nightly to inland sites. Paper records scan into boring formats. When the next storm comes, the lights blink, then return. Nothing mystical happened. The ledger learned to reset without breaking, and the arrow kept pointing forward because someone paid the bill. Local anti-entropies. Life, learning, and order from flux. If horizons write the budgets and surfaces keep the ledger, here's the stake where it hits your kitchen table. Your daily wins over mess aren't exceptions, they're licensed moves. Order blooms whenever a system sips a gradient, exports heat, and copies useful structure faster than noise eats it. That isn't poetry. It's thermodynamics for open systems with receipts. Action first. Ilya Prigogine showed that far from equilibrium systems don't just decay, they self-organize. Pour cream into hot coffee and eddies stand up before they smooth, transient order fed by a temperature difference. Drive heat through a catalyst bed and reaction fronts snap into waves. A river speeds up and lanes appear, alternating threads that reduce friction. These are dissipative structures, islands of pattern that pay their rent by pushing entropy out the back door. They live on flux. Zoom out to a summer city. Power plants burn fuel, transformers hum, air conditioners dump heat into alleys while cold air silently congeals in apartments. The grid is a refrigerator at national scale, local entropy down, global entropy up. The ledger smiles because the bills add. You feel the arrow as comfort while the atmosphere takes the heat. That isn't hypocrisy, it's the only way order survives, by hitching to flows that can eat the cost. Now walk into a server room. Racks glow, fans scream, a heat plume drifts to the plenum. That waste is the price of clean computation. Bits erased, caches flushed, registers reset. Landor stands by the door, each irreversible operation leaks heat. A green data center isn't a loophole, it's an efficiency upgrade. Better airflow, liquid cooling, hot-cold aisle discipline. Every trick lowers the joules per durable bit. Cleaner ledgers, cheaper receipts. Micro story. A startup moves into a shared lab with racks jammed against a wall. Machines throttle, jobs fail. A tech maps hotspots with a $99 infrared camera, flips the layout, adds blanking panels, tunes fan curves. Error rate drops, throughput climbs, power draw falls. Nobody wrote new code. They redirected a gradient. Order improved because waste got a cheaper exit. Brains play the game at furious speed. Neurons are prediction engines carving order from sensory noise by burning glucose and oxygen. Spike trains encode surprises. Synapses strengthen on success. The rest gets pruned. Sleep compresses, replaying and downscaling patterns so tomorrow's attention isn't flooded. You export entropy as heat in Code 2 so that compressed models, skills, maps, stories can survive. Learning is a dissipative structure with targets. Quantum Darwinism echoes this at the floor. Decoherence selects pointer states, robust variables that survive contact. Then the environment copies them. Photons scatter from a chair into trillions of directions. Many observers read the same story without touching the chair. Redundancy looks wasteful until you remember error correction. Copy storms stabilize facts. Heat is the cost. Agreement is the benefit. Complication. You can't outsource the bill to nowhere. When order pops up without a visible power line, you're missing the supply chain. A coral reef is an entropy pump driven by sunlight. A hurricane is a heat engine fed by warm ocean. A university is a knowledge engine powered by grants, cafeterias, and bus routes. Every institution that stabilizes truth installs flows, food, money, attention, and plumbs those flows through copying mechanisms. Papers, code repositories, recorded lectures, standardized gear. Sustainable means inputs and outputs can run indefinitely within the patch's budget. Here's the habit that turns physics into leverage. Treat agency as engineering. You can't conjure an uncaused act, you can tune conditions that shape the next act. Move queues, reduce friction, raise redundancy. The results look like good design, checklists on lab doors, sensors with dumb backups, sunlight on desks, routers that sleep at night, whiteboards photographed and archived, meeting notes in public docs, code mirrored across continents. These aren't quirks. Their surface moves, pushing bits to interfaces where many eyes can copy them, making facts expensive to erase. A human moment. A community clinic digitizes paper charts. At first, chaos. Then they add rules. Every lab result lands in an inbox mirrored to 2 staffers. Summaries auto-email to patients. Weekly huddles handle edge cases. A hot spare laptop waits in a drawer. A thunderstorm kills power for 6 hours. Intake continues on battery. The on-call physician still sees medication history. Nothing mystical happened. Redundancy outran noise. Respect one more constraint. Complexity thrives at medium entropy. Too cold, frozen, and nothing changes. Too hot, chaotic, and patterns can't hold. Cities, biomes, markets sit in that band. They need slack. Over-optimization, just-in-time everything, collapses under small shocks because there's no reservoir to absorb error. The efficient frontier that lasts includes buffers, empty hospital beds, extra bandwidth, cash reserves, time to think. Those wastes are anti-entropy in waiting, the fuel for recovery when gradients flip. Now put horizons back in frame. Your patch's storage quota lives on its edge. The facts that outlast you will be the ones that ride interfaces many can query. Open data, shared formats, transparent pipelines, local copies in many hands. If information costs heat, efficiency decides which stories the universe keeps. Gossip burns out, verifiable records persist. And meaning, in a budgeted world, is just low-error feedback loops that survive latency, projects you make redundant across space and time. So no, life doesn't defy the second law. It weaponizes it, drinking gradients, dumping heat, turning flux into form. Engines, ecosystems, neurons hum the same tune. Export disorder to build order. If that feels small, widen the view. It's the only way any arrow you care about gets a second act. And in the next beat, we'll meet the selection rule that makes crisp worlds inevitable when copying wins. Efficiency as law, minimal commit, maximal redundancy. Here's the rule that keeps showing up wearing different badges. Nature stabilizes facts by spending as little as possible on state and as much as necessary on copies. Minimal commit, maximal redundancy. That isn't branding. It's how a quantum world turns crisp without an editor, and how records outlive their makers in noisy environments with tight budgets. Start microscopic. A quantum system in superposition brushes an environment, a few stray photons, a vibrating lattice, and rapidly decoheres. Out of a huge menu of possibilities, only a tiny set of pointer states keeps surviving contact. Dusk grain positions, loop currents, robust field amplitudes. The rest fades because those alternatives demand delicate phase relations the world won't subsidize. Decoherence is selection by efficiency. The states that don't need constant maintenance win, because the environment will maintain them for free. Then quantum Darwinism escalates the game. Those pointer states get copied into many fragments of the environment. A chair's position writes into quadrillions of photons. You and I can both read it without touching the chair. Redundancy looks wasteful until you see the payoff, objectivity. Many readers, same story. The system commits to a course description, the pointer basis, and spends budget broadcasting it. Alternatives that require fragile coherence never get funded. They wash out. A human beat. A grad student runs a delayed choice experiment, when which path information is available, even in principle interference dies. When that information is erased, fringes return. The toggle isn't consciousness, it's whether path facts can be redundantly copied. Make path info cheap to copy and the universe pays for a particle story. Make it impossible to copy and the wave story stays affordable. Minimal commit, maximal redundancy. Landor keeps the books. Every irreversible step, erasing a bit, resetting a register, dumps heat of at least KT-ln2 per bit. That price pushes computation toward reversible tricks and memory toward compression. Keep what many queries demand, infer the rest on the fly. In practice, we accept small heats to make big gains. Structured logs many machines can parse, checksums that let distant readers catch errors, parity bits that rescue files after a flipped electron. Overhead stays minimal. Redundancy concentrates where it matters. Micro story. A student designs an exquisite bespoke binary format. It's compact and unreadable. A storm rolls through. A collaborator can't decode the bytes. A week of data is effectively gone. They rewrite the pipeline. Self-describing format, human-readable headers, auto-plots, nightly mirrors to 2 continents. Storage overhead rises by a few %. Recoverability jumps to near cert. The new rule sticks. Bits that strangers can't copy don't count as facts. Scale to cognition. Brains are prediction machines under metabolic budgets. They compress torrents of sensory data into sparse generative models, then broadcast high-value summaries, words, sketches, rituals across groups. You don't store every pixel, you keep features that predict reward and risk, then multiply copies in culture, recipes, laws, code. Details you can infer cheaply aren't kept explicitly. The ones you can't infer get made redundant. That's why language exists. Maximal redundancy on a minimal alphabet. Holographic habits echo this law. In add-s-CFT toy worlds, bulk information is redundantly encoded on the boundary. Lose some boundary patches and quantum error correcting structure lets you reconstruct simple bulk operators anyway. You didn't pay to store every voxel. You invested in a code that recovers the part of the volume anyone can actually query. Minimal commit, just enough degrees of freedom at the edge paired with maximal redundancy, encoding across many modes. Geometry itself looks like efficient entanglement layout. Bring it back to the street. Institutions that endure keep commitments sparse and copies loud. Simple standards, open formats, boring protocols, lots of mirrors. Objective truth is a copy storm across surfaces you can audit. Lab notebooks with timestamps, pre-registered plans, data in public vaults, analysis scripts that rerun. Fancy ontologies nobody can parse die in deserts. The world behaves the same way. Pointer states, not esoterica. Photons, not hidden whispers. Complication worth facing. Redundancy can smother. Too many copies of the wrong thing spam, rumor, cached mistakes, clog channels, and tilt the arrow toward noise. Efficiency isn't hoarding, it's curation. Keep the model minimal, keep the broadcast selective. Align redundancy with verification. That's why provenance and error bars matter. It isn't enough to shout. You have to shout with receipts. A human moment. A small observatory loses a disk. They debacked up images, lossless, redundant. They hadn't backed up calibration frames or processing scripts. The photons survived, the meaning didn't. A week later, they adopt a rule. No dataset is real unless a stranger can reproduce the figure from the vault. Extra copies bloom of the code, not just the counts. The signal returns because the recipe got made redundant. Meanwhile, horizons gate what can stabilize. In a causal patch with finite entropy, there's a ceiling on distinct facts that can be live at once. The world looks crisp because it picked a skinny set of stable variables and paid to copy them everywhere. Unasked alternatives faded by design. No minds required. Contact is enough. Efficiency is just the second law with taste. Don't waste bits you can infer. Do waste energy on redundancy when it purchases shared reality. So the playbook is short. Minimize what you must keep explicit. Maximize the ways the few important bits can be read. Put facts on interfaces, light, sound, shared formats that many independent paths can carry. Accept that erasure has a bill and spend it on clarity, not clutter. Nature follows this policy from quanta to horizons. Adopt it and your work will outlast your battery. Horizons as interfaces, budgets, bandwidth, and quotas. Now pull the lens to the real gatekeepers. Horizons aren't walls, they're interfaces, API endpoints carved by geometry that decide which questions can return answers, at what rate, and at what cost. The stakes are blunt. Inside your horizon lives a finite storage quota and a fixed bandwidth for stabilizing facts. Everything we've called reality is what those quotas let us copy and cross-check. Start with the menu. There's the particle horizon, the farthest light that's reached us since the Big Bang. It's a time limit, not a painted dome. There's the event horizon, the boundary of what can ever signal us, even if we wait forever in an accelerating universe. And there's the apparent horizon, locally defined, where outward directed light hovers at the threshold between expanding away and being dragged back. They aren't the same, and they're observer dependent. Shift your motion, change nearby mass, and your apparent horizon shifts. Different dashboards, same backend. Thermodynamics sneaks in with geometry's stamp. In a de Sitter-like universe with dark energy, your causal patch has a Gibbons, Hawking temperature, and an entropy proportional to its horizon area. That's the boundary ledger again, a finite number of distinguishable states accessible to you, scaling with edge, not volume. The interface hisses with a minimum noise floor. Not warmth you toast your hands on, just the signature that the screen has microstates and therefore a storage limit. Translate that into policy. Inside your light cones, signals can circulate, redundancy can build, and facts can stabilize. At the horizon, the ledger tightens. Correlations beyond it aren't fake or destroyed. They're out of scope for you, cached elsewhere in the global state, unavailable to your calls. That's why objectivity is local. Tables and stars are real for cohorts that can copy the same bits. Across horizons, the same table stops being a coherent question because the interface won't return that join. A human moment. A radio team pings a deep space probe as it slips towards solar conjunction. Static climbs, the sun's corona scatters phase, bit rates fall. They throttle back. Lower modulation, stronger error correction, longer round trips. The probe didn't vanish. The link budget changed. Horizons feel like that. Latency, noise, quotas, physics telling you how much truth can be stabilized per second. Put black holes back on the board. An event horizon sets a one-way interface. Information about what falls in isn't missing from the global ledger. It's re-encoded at the boundary and after the page time, recoverable in principle from outgoing radiation. The bandwidth is cruel, astronomical delays, impossible decoders, but the rule stands. The interface accounts for bits and meters their return. Smoothness for infallers survives because reconstruction depends on access. No single observer queries both dashboards without breaking causality. Cosmology hums the same tune. Accelerated expansion pushes distant galaxies beyond our event horizon. Their stories keep unfolding in their wedges. Our interface won't deliver those packets. Meanwhile, new photons slide across the particle horizon daily, adding grains to our shoreline of knowable facts. Observable universe isn't an aesthetic boundary. It's a live budget update. What's loaded in your instance, what's still in transit, what will never arrive. Here, S where quotas bite agency. Finite horizon entropy means finite distinct facts can be present and retrievable within your patch at once. The world looks crisp because most of those bits are tied up in redundant encodings of a sparse set of pointer facts, positions, fields, durable records many channels carry. You don't suffer for not storing everything. You thrive by broadcasting the right few things widely. Push facts to interfaces, light, sound, shared formats, and they persist. Hoard them in corners with no copies, and they decay with you. Micro story. A telescope simulating signals near a cosmological horizon watches a source fade into the bath. The team debates whether the last bits ever arrive. The math says no for us. Forever is too short against accelerated expansion. Someone writes cached elsewhere on the whiteboard and underlines it twice. They stop designing longer integrations and start designing cross-patch comparisons while the window is open. Observer dependence without mysticism follows. Two users hit the same backend with different permissions, accelerations, world lines, wedges, and receive consistent but different slices. The apparent horizon for a rocket differs from that of a coasting ship. Thermal baths shift, latencies change. No contradiction appears because no one can combine returns geometry forbids. Facts are relational to access, not to will. The ledger's ethic turns practical. If you want truth to outlive weather, copy it to many surfaces inside your patch. If you want collaboration to scale, design protocols that fit the bandwidth. Simple checksums, reproducible pipelines, mirrors far apart. If you want institutions to endure, reduce dependence on single links, add slack for round-trip delays, and keep formats boring enough that strangers can parse them. Horizons won't budge, design will. One more habit. Treat questions like API calls with rate limits. Expensive queries, rare data pulls, fragile samples, deserve buffering and batching. Pre-registration, standardized instruments, automated logs. Cheap queries, public dashboards, daily checksums, earn high frequency. Spend bandwidth on verification where it buys the most shared reality. A last beat. Quotas don't shrink meaning, they prioritize it. A finite patch entropy pushes culture toward compressive clarity and redundant honesty. The universe rewards receipts staged on interfaces others can query. Beyond that edge, humility, your questions time out. Inside it, budget well, and your records will ride the light a very long time. The lie in Entropy rules everything, what it missed. Here's the confession the doom story never filed. Entropy isn't a tyrant with universal jurisdiction. It's a policy that bites only where access exists, budgets are finite, and records are counted. We mistook a bookkeeping rule for a destiny, and in doing so, we ignored the clerks, horizons, surfaces, and selection rules that decide what actually stabilizes. Start with what the mantra got right. Typicality is real. Left alone, a closed system wanders toward macrostates that occupy more phase space. Eggs scramble, heat spreads, inboxes bloom weeds. But what you care about isn't closed, and nothing you depend on is left alone. Reality runs on interfaces. Refrigerators dumping heat, brains burning glucose, telescopes turning photons into bits, labs exporting entropy to keep fragile order alive. The second law never promised the death of meaning. It promised a price. Then the shortcuts that turned a law into a myth. First, we treated entropy as absolute disorder instead of description-dependent counting. A macrostate is a choice about distinctions you keep. Change the course graining, change the number. Second, we forgot that horizons bound who can count what and when. Entropy in your patch is written on your edge. Beyond it, the book isn't yours to audit. Third, we skipped the invoice. Information is physical and expensive. Copying stabilizes facts. Erasure pays in heat. Redundancy outruns noise. Your day's crispness isn't an accident of decay, it's a victory of policy. Meanwhile, the big ledgers waved. Black holes swapped volume for area and forced counting at boundaries. In 1972-1974, Bekenstein and Hawking pinned entropy to horizons and temperature to gravity. The page curve, computed with islands, showed information isn't destroyed. It's readdressed to regions your access eventually includes. In 1997, Maldacna's add SCFT turned geometry into entanglement accounting. In 2006, Ryu Takuyanagi gave a ruler for entropy as minimal area. Quantum Darwinism explained why the world looks classical. Pointer states survive because environments copy them. None of this is a loophole. It's the second law with units specified, domains marked, and interfaces labeled. A micro story. A simulation team tries to store every collision in a supercluster box. They run out of disk in a week. They pivot, keep long wavelength modes, track halo merger trees, drop microscopic chatter that doesn't move observables. Their mock sky improves. The universe plays the same trick at scale, commit minimally, broadcast redundantly, recover what matters on demand. The rest isn't lost. It's implicit in constraints you don't need to ask. Now the sting. If the law is statistical, conditional, and patch-bound, agency isn't a fairy tale, it's engineering under constraints. You don't move horizons, you budget for them. You don't abolish erasure, you spend it on clarity. You don't fight typicality head-on. You route flows so your records, laws, data, skills get copied to interfaces many can read. Institutions that grasp this look like refrigerators, local anti-entropies, powered honestly, venting heat where it can be handled, keeping perishable facts cold. What about gaps? Our patch looks de-Sitter-like and lacks a clean holographic dual. Conformal cycles and bounces remain unproven. Island formulas translate ADS lessons with care. Fine mark the map. Backend under construction. Front-end rules still serve. Count at edges, respect access, prefer redundancy, pay your bills. Reality doesn't demand perfect theory to reward good practice. A human moment. A lab nearly loses a week of measurements when a single laptop dies. The postdoc proposes a rule. Nothing exists until a stranger can rerun it from public vaults. They switch to boring formats, mirrored storage, nightly repro runs. The heat bill ticks up. So does resilience. Entropy didn't relent. It got a counterparty. Here's the fix to the lie. Entropy doesn't rule everything. Budgets do. Horizons enforce them. Surfaces tally them. Efficiency decides which bits win. Arrows emerge, reset locally, and might recycle globally. Endings look like compressions, information recoded at edges, not voids. Live as though fate is decay and you hoard and fade. Live as though budgets are real and you copy and last. Translate that into moves. Keep commits minimal. Make receipts maximal. Aim facts at interfaces others can query. Prefer open formats, reproducible pipelines, cross-check datasets. Price erasure, design for latency, add slack. And admit the unknowns. De Sitter's dual Ian tests, full decoders for the sky. Because honest ledgers are the only ones that survive audits. One last beat. Remember the fridge, the lab spin echo, the page curve bending, the telescope's shoreline, the astronaut in a thinning sky. None of them cheat the second law. They negotiate with it, pushing structure to places it can persist, paying the bill in heat and letting boundaries keep the books. The doom story missed the accountant. The universe keeps records. Your job is to help. Life inside a budgeted universe. Agency, meaning, design. If horizons write quotas and surfaces keep receipts, then living well becomes accounting with heart. Agency isn't a miracle, it's engineering under constraints. Meaning isn't cosmic permission, it's a loop that pays for itself in rough weather. Design is where those two meet, shaping flows so facts outlast storms. Start close. You're an open system. You don't resist entropy, you redirect it. Sleep, food, light, movement. These aren't lifestyle tips, they're firmware. Morning light stabilizes clocks so attention runs cheaper. Protein-forward meals flatten jitters that hijack plans. Movement lifts signal to noise in the brain. Sleep compresses memory so tomorrow's model is lighter. Physiology is your first gradient. Spend it on structure. Now one layer out. Projects that survive share three traits. Minimal commit, maximal redundancy, honest cost. Minimal commit means clear interfaces, simple formats, public repos, boring protocols, short checklists. Maximal redundancy means copies in many hands, mirrored storage, reproducible pipelines, backups you can restore blindfolded. Honest cost means budgets you can feel, time blocks, power limits, attention caps, so you don't spend next week on a promise you can't keep. Micro story. A small radio observatory loses power mid-survey. Years ago, that was a week gone. Now the pipeline is scripted, data land in a self-describing format. Calibration frames auto-upload to 2 continents. Nightly reruns regenerate figures from raw. When the lights return, the archive is intact and the plots refresh themselves. The team eats cold pizza and laughs at what would have hurt 5 years ago. They paid a small heat bill on redundancy last month and bought resilience today. Scale up to institutions. They're refrigerators for truth, not to look impressive, to keep perishable facts cold by dumping heat elsewhere. That means funding flows you can audit, governance that tolerates error correction, and rituals that push copies to interfaces anyone in the patch can query, preprints, registers, logs, open data. It also means buffers by design. Slack in schedules, extra seats in classrooms, spare beds in hospitals, local caches of critical supplies. Efficiency that erases Slack collapses on small shocks. Efficiency with Slack makes anti-entropy portable. Meaning learns to speak thermodynamics. It isn't a mood, it's the felt drop in prediction error when values, capabilities, and environment mesh. You don't summon it by decree, you nurture it by aligning loops that return clean signals, a weekly clinic that runs on time, a neighborhood garden that keeps feeding, a long baseline array that outlives its founders. Their reward isn't applause, it's reach, truths that remain true after you're gone. A human beat. An engineer retires from a community water project. He doesn't frame the plaque, he checks the binder, maintenance checklists, parts suppliers, emergency scripts, phone trees, laminated in the pump house. Teens on bikes know where the shutoff valve lives. A storm hits a year later, the system returns in hours. A text arrives, a photo of clean flow, no fanfare. That's what redundancy feels like, quiet continuity. Design under horizons means local humility and long ambition. Local humility. Respect light cones, latency, bandwidth. Don't build systems that depend on instant sync. Build ones that degrade gracefully and reconcile with checksums. Long ambition. Propagate records along channels that outlast you. Open formats, cross-institutional agreements, mirrored archives, simple rules a stranger can follow. Keep the model sparse and the broadcast loud. Complications deserve honesty. Copy storms can spread garbage. The cure isn't copying less, it's copying with receipts, provenance, error bars, adversarial testing, randomized audits. Open without curation is spam. Closed without redundancy is rot. The middle path is boring and strong, standards whose boredom is a feature. Meta-agency matters. You can't choose from nowhere. You can choose to reshape priors and environments so the next choice tips where you'd endorse it. Move cues, pre-commit. Add friction on vices. Add glide on values. Build social contracts that catch you when you wobble. That's physics turned inward. Micro story. Two friends promise to practice twice a week. They block a shared calendar. They keep a silly scoreboard on the wall. Missed sessions cost $5 to a charity they dislike. After a month, sessions feel less like willpower and more like gravity. The ledger changed hands from try hard to copy the rule. The heat bill, almost never paid. The result, a habit both can measure. Zoom back to horizons. They tell you what can truly scale. Work inside your patch. When a signal needs new reach, bridge patches. Translate, partner, relay. Aim ideas at interfaces that survive. Plain speech, open tools, cross-checked facts. Accept that some ambitions outstrip the quota, shrink their state until they fit. The world rewards designs that travel light and copy well. So the playbook, minimize what you must keep explicit. Maximize the ways the few important bits can be read. Put facts on interfaces, light, sound, shared formats that many independent paths can carry. Price erasure. Design for latency. Leave slack. You'll get fewer miracles and more persistence. One last human moment. A teacher keeps a drawer of one-sentence notes from students. On rough days, she reads one. It's a tiny jolt from a long-horizon project, a precision bump delivered on demand. She didn't conjure warmth. She built a drawer that renders it when needed. Resolution and meaning. Entropy didn't lie, our picture did. Remember the thermometer dropping while the room got louder? That system steered itself because the ledger was open. Horizons set budgets and surfaces kept receipts. Your future works the same way. Subscribe for more untold physics with handles. Watch next. Dark Energy's horizon and your patch's storage quota. Tell us one loop you'll make redundant this week and who gets the copy.